To my YouTube channel. Today we're still under Mechanotechnics N6. We're still under Conical class, right? So if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. So in this question, example 8, we've given a conical class transmit 210 newtons at 1250 rests per minute. The outer diameter of the glass is 350 and the included cone level is 25. The glass surface width is 65 and coefficient is 0.2. Then said assume it's a uniform way. Calculate the axial force required to transmit this torque. Axial force that required to transmit that force, isn't it? Okay, so we can have our dot. I like I like I just like to let us have our dot. We have the torque of 210 Newton per meter and it is 1250 rests per min, and outside diameter of the 350 the same as 5 meter, and the included angle which is 25 degrees. Divide this by 2. Right, 25 by 2 will be 12.5. Must be a semi-groove angle. Then coefficient of friction, we're given the coefficient of friction 0.2 or 0.2. This is what we have there, and the width 65, the same as 0.065 meter. So we have this. So guys, so question A says we should calculate the axial force. We should calculate the axial force. We know there would be a limit to axial force. You know that axial force is equals to torque multiply by sine alpha divided by coefficient of friction multiplied by RF. So here it's our limitation here. So we're supposed to calculate RF, right? Remember, RF is equals to R plus R divided by 2. So we're supposed to have this and that small one. So this we have, but this one we don't have. So nevertheless, we have outside diameter. You can divide that by 2. If you divide this by 2, you'll get this to be 0.1, yeah, 0.175, 0.175 meter, right? 0.35, 0.175 meter. So we have this. So to find that, guys, remember conical class, we have this r minus r width here, our alpha. So apply opposite over adjacent. To apply what there? Apply our trig ratios, which is trig ratios of what? Of sine. Apply the trig ratio of sine there, right? So sine that angle will be r minus r divided by width. This is sine, this is 12.5, isn't it? Yeah, because it was 25, then this will be 12.5 degrees. R we know, the big R is simply 0.175 minus small r we don't know. Then here it's a width we given. There the width it was 0.065, 0.065. Then can make r the subject, you multiply there, right? If you want R, then you subtract that. R will simply equals, you multiply there, will be 0.065 multiplied by sine 12.5 degrees. Since you've multiplied, then you've multiplied that side also there, you subtract by that. So this will be negative R, then you minus again here 0.175. I don't want the negative. If I divide by negative both sides, this will simply equals to 0.175. This is the same as 0.175 minus this. If I punch this in on my calculator, minus the same as minus 0.065 sine 5 here multiplied by what, sine 12.5 degrees. This is what we have. Then R, if you multiply this, R will simply equals to what? What I can say, this will be approximately to same as 0.161. I will make that 10 in meter. Then yeah, so RF simply equals to 0, remember it's R plus R divided by 2. This will simply equals to, we know big R is 1 over, so is 1,075 plus the one we've just calculated, then divide by 2. Then this will simply equals to 0,168 meter. So we have this now. There's no limitation. You can calculate the force. Remember, the force, you've taken it from this equation of the torque. Remember, torque is called coefficient of friction multiplied by axial force multiplied by our RF divided by sine. So this is what we want. If you make that the subject of the formula, you'll get that F will multiply by that will be T sine that angle, then you divide by these two, divide by coefficient of friction R, then here we'll have RF. So yeah, you can substitute torque where it was given. It was 110 multiplied by sine, the angle is 12,5. Then coefficient of friction, what is coefficient of friction? 0.2 multiplied by RF, we've just calculated it, 0,168, 0,168. Then let's find the axial force, which simply equals to what? 1353 Newton. We have that. B, we should calculate what? The maximum, check there, the maximum pressure at the inner radius of the cone, the maximum. B, maximum power, P max is equals to axial divided by 2 pi. Here you must be equal to R minus, must be simply small r outside, which R minus R like this. You understand? Check. If it's a maximum, you have little r outside. But if you are talking about P min, if we are talking about minimum pressure, you'll have F axial over 2 pi, but your R here will be big R. That is the difference. The difference is between these R's. You understand? So nevertheless, let's calculate our maximum pressure. Our axial we did calculate is 135. It's 153. What was that? 153. Yes, divided by 2 pi. Then our R there, small r, is the one that you've calculated it, which it was 0.175 into 0 comma small r big R. Small r it was what? Okay. Ooh, what small r it was 0. The one who calculated it, what was it? Or 0 0.61. 0 0.16 here, 0 0.161, or 0 0.161 into big R is 0 0.175 minus 0 0.161. So this, if we punch this on a calculator, supposed to get that UP max to be equals to 95.5 kilopascal. So that is it, guys. That is it. So thank you for watching. Please subscribe to my YouTube channel if you have not subscribed yet, and then if it is your first time watching this video, please subscribe. Feel free to comment and like and share this to your fellow classmates. All the best. Thank you for watching.